Yeah, so let's wait for some people and then start. Am I audible? Do let me know in the chat if the stream is working fine and if the audio quality is okay or not. Is there any kind of stuttering or anything like that? Yeah, audio is working right. Yeah. So I found the pen. So we can start with the video, I think. So basically, I will be talking about the coordination problems for today. So there were, I think, 4 problems in the way. So we got 4 problems. I was able to solve 3 out of them. So I will be discussing those 3 problems, and I will like tell you the 4th problem, but I don't yet know the solution on how to solve that. Maybe you guys can give me hints. So the first problem was quite easy. So in the first problem, we were given an array, right? Let's say A1, A2, A3, A5 up to N, right? We were given an array like this, and we had to find a subsequence. We had to find a subsequence with the maximum score, the maximum. And how do you find the score? Score was defined as the minimum element in the array into the size of the subsequence. The size of the subsequence. Right, so this was the first problem. So given an array, you had to find a subsequence with the maximum score, right? And you had to print the maximum score. So the score was defined as minimum element of the subsequence into the size of the subsequence. So that was the score, right? So as you can think about this, the problem was really easy. So all you had to do was just sort the array, and we will iterate over, or we will fix the minimum element. We will iterate over or fix the minimum element, right? As you can see, our score is equal to the minimum element into the size of the subsequence. So as there are only n elements, right? So the possible values of minimum element are only n, right? So there can only be n minimum possible elements. So we will fix this minimum element, and for this minimum element, we will maximize the size of subsequence. We will maximize the size of subsequence. And then we will try to find the score, and then we will try to find the score for this, right? So that was the solution. So it goes something like this. So if you have an array a1, a2, a3, so on up to an, right? You can sort this. Okay, sort this. So you will get a new array a1 dash, a2 dash, a3 dash, until an. So first we will assume that our element a1 dash is the minimum element, right? So if our a1 dash is the minimum element, now for this minimum element we want to maximize the size of subsequence, right? So as the array is sorted, so if our a1 dash is the minimum element, then all the elements greater than this are larger than a1 dash, larger than or equal to a1 dash, right? So there is no harm in including them in the subsequence, right? So our subsequence will be this. Our subsequence will be the whole array. So our score will be how much? It will be a1 dash into n minus 0, right? So that will be the score for 1, right? Similarly, we can assume our element a2 dash is the minimum element. Our element a2 dash is the minimum element. And as our a2 dash is the minimum element, we cannot include a1 dash anymore, right? Because a1 dash is smaller than a2 dash. So yeah, so we can just take the whole array after a2 dash, right? So score for 2 will be how much? Score for 2 will be a2 dash into n minus 1. Similarly, you can find the score for all the elements, right? Score for 3 will be how much? It will be a3 dash into n minus 2. And similarly, in the end, score of n will be how much? It will be an dash into n minus 1, right? So yeah, so that will be the score for every element, and your overall score will be how much? Your maximum score will be maximum among all these scores. So score 1 maximum among score 1, score 2, score 3, so on up to score n, right? So for every element, you fix it to be the minimum element, you maximize the size of subsequence it will belong to, and then you find the score for that element, right? So similarly, you find n scores, and your maximum score will be the maximum score among these n scores. So that was the first problem. If you guys have some doubts, do let me know in the chat, and I will try to answer them. So that was it for problem 1. So let's move on to the second problem, which was a bit harder. So I think the problem 2 was quite ambiguous, right? And the problem statement for this problem was very bad in my opinion, right? Because it was very hard to understand the problem, and even in the sample inputs, it was really hard to figure out what was happening, right? It took me around 15 or 20 minutes to figure out the problem itself, but the problem was really trying to say, right? I had to like see the expected output for a few sample cases, and then I kind of reverse engineered how the problem was working, right? The statement was very bad for this problem, I must say. The problem was not that hard. The problem statement made it much harder to figure out the problem. Yeah. So for second problem, you had been given a binary string. So you were given a string s, something like this, 1 0 0 1 0, let's say, right? Something like this. And what you had to do was you can take any substring. You can take any substring of this string and flip the bits. For example, if our string is equal to s, right, and we have 1 0 0 1, then we can apply an operation on this. We can take any subarray. For example, let's say we take this subarray and we can flip it, right? So our new s will be how much? Our s dash will be equal to 1 1 1 0 and again 0, right? So we flip these 3 bits. So that is what we call an operation, right? So that was the first part. So you were given a binary string, you can apply an operation on it. The operation is you can take some substring and flip the bits. So the second of the problem is, right, after you apply one operation, right, you have been given some starting string s, you have been given some starting string s. Let's say you apply one operation on it. and you get a new string s dash. You get a new string s dash. And for this s dash, you had to find the maximum pairs x comma y such that x plus y is equal to s and x XOR y is also equal to s. Sorry, s dash. So that was the problem. So after applying one operation on s, you will get some string s dash. And for this string s dash, you must find the maximum pairs, the maximum number of pairs x comma y that we can have such that x plus y is equal to s dash and x XOR y is equal to s dash. So that is the problem. So how can we do this? So if you think about this, we have our string s dash, right? So what are the kind of pairs that we can have, right? So we want our x plus y equal to s dash and we want our x XOR y is equal to s dash. So basically we want our x plus y equal to x XOR y equal to s dash. And what are the conditions for the XOR? We know that 0, 0, XOR of 0, 0 is equal to 0. We also know that sum of 0 plus 0 is also 0, right? So the following condition is okay. The following condition is okay. We also know that XOR of 0 and 1 is 1 and XOR of 0 plus 1 is also 1, right? So this is also okay. Condition is also. But if we have something like, let's say 1 1 and 1 1, then in this case, if we XOR these, we will get 1. But if we add these, we will get a 10, right? And we will get a redundant one. We will get a redundant one, right? So the following condition is not okay. The following condition is not okay. So these are the three conditions that we can have. So now we will, these did not come in my OS. Yeah, so like I think there was a set of problems. So I don't think everybody got the same problems, but I will be solving the problems that I got in my OA. Right, so I got 4 problems. I was able to solve 3, so I will be solving these 4. Yeah. So these are the 3 conditions. So if you have been given let's say a string like 1 0 1 1 0, right? This is, let's say, your s dash. Then in x and y we have a 0, right? So the only possibility here is that x is also 0 and y is also 0, right? Because we know our x or y has to be equal to 0, right? And if we have a 0, the only possibilities are 0 0 or 1 1. And as we have seen here, that if you take 1 1, right, and when you add them you will get a 10, right? So this will not work. So if you have a 0, the only possibility is that you also set x 0 and you also set y 0. And now we have a 1. So what is the condition here, right? If we have a 1, we can have either 0 1 or we can either have 1 0, right? We can either have 0 1 or we can either have 1 0, right? We can either have 0 1 or we can either have 1 0, right? So there are 2 possibilities. There are 2 possibilities here. Similarly, we have 1 again. So again there are 2 possibilities. There are 2 possibilities. Again for this one we again have 2 possibilities, right? And for 0, there is 0 and 0 again, right? So as you can see, how many possibilities do we have? We have 3 ones here. We have 3 ones, right? So our number of possibilities are 2 into 2 into 2, right? Because for every one there are 2 ways to place it, right? Either we can use x0 and y1, or either we can use y0 and x1, right? So for every one there are 2 possibilities. So if my s dash has, let's say, z number of ones, let's say my s dash has, let's not call this z, right? It will be confused with 2. Let's not call it z. Let's say my s dash has x number of ones, then the number of ways to distribute x comma y will be how much? It will be x comma y, and the number of ways to distribute x comma y will be how much? It will be 2 the power z, right? Because for every one there are 2 possibilities. Oh, so sorry, not z, x. We are already using x. Not call it x either. Let's call it some random variable p, right? So let's say s dash has p ones, then the number of ways to divide x comma y will be how much? It will be 2 the power, right? But it will not be a 2 the power p also, because in the problem we were told that x comma y along with x plus y equal to s dash and x or y equal to s dash, x plus y should also be greater than equal to 1. X comma y should also be greater than equal to 1. And in this case, there will be two possibilities where x will be equal to 0 in one possibility and y will be equal to 0 in one possibility, right? So we also have to subtract -2 for these two possibilities, right? So now we know for a given s dash, number of pairs xy such that x plus y equal to s dash and x or y equal to s dash, where x comma y both are greater than equal to 1, are how much? If s dash has, let's say, equal to p1s, then the number of pairs of xy are 2 the power p minus 2, right? So now we know that if we can increase the number of ones, then we can also increase the number of pairs, right? So to maximize number of pairs x comma y, we just need to maximize number of ones in s dash, right? So that is the solution. So to maximize the number of pair x comma y, you just need to maximize the number of ones in s dash, and for that number of ones, just calculate the number of pairs. So that will be the solution. So how can we count the maximum number of ones that we can have in s dash? How can we count the maximum number of ones that we can have in s dash? It is pretty simple, right? If we have a string, let's say my string s is equal to 1 0 0 1 0, right? And I have my string s dash, so I want to maximize the number of ones, right? So what I want to do is to maximize the number of ones in this, I want to flip maximum number of zeros. Right? So to do that, I can assign -1 to a 1 and +1 to a 0, +1 -1 plus, right? So if I do that, I just want to flip the maximum number of zeros, right? Because if I flip the maximum number of zeros, then I will be able to maximize the number of ones in my string s dash. So if I want to flip the maximum number of zeros, I will assign +1 to zeros and I will assign -1 to ones, and I will then just find the maximum subarray sum. Subarray sum, right? Because if sum of my array is maximized, then it will have max number of zeros. And if I will flip this max number of zeros, it will generate maximum number of ones, and these maximum number of ones will generate max pairs x comma y. So that is the solution. So you can just convert. So you have your string 1, right? 1 0 0 1 0. You can assign -1 to ones and +1 to zeros. Then you can just find the maximum subarray sum, right? So the maximum subarray sum is here how much? It is 3. So we will flip this subarray. So my s dash is how much? My s dash is 1 1 1 0 1, and in s dash we have 4 ones. So my number of pairs x comma y will be how much? It will be 2 the power 4 minus 2. Which part, bro? Codex. Right, there's a lot of logic here. Which part do you want me to explain again? Codex, are you here? Do let me know which part do you want me to explain again. Maths. The whole thing is maths, bro. Which part of the maths? The bitwise OR part, or the number of how do we count the maximum number of ones? Which one? Hard to count max number of ones. Yeah, so that part. So you see, in S dash, we have to find the max number of ones. Right? We have to find the max number of ones. And we know that we are getting S dash after flipping some part of S, right? We have the max number of ones in S dash. So that means we want to flip max number of zeros, in S, right? For example, if my S is how much? Let's say my S dash is equal to S dash is something, my S is equal to 10110. Not this, I will take something. Let's say my S is equal to 1010, right? Let's say if you flip something like this, if you flip this one, we will get how much? We'll get 10000, right? But all these zeros are useless, right? All these zeros in S dash are useless, right? All these zeros are useless. These are not useful to me, right? So what you want to do is, you don't want to copy over zeros from S. You don't want to copy over zeros from S. You want to flip those zeros. Right? So you just want to find some subarray where number of zeros is more than number of ones. Number of zeros is more than number of ones, right? For example, in S, you find some subarray, right, which has, let's say, 50 ones, and let's say 75 zeros. So if you flip this to S dash, in S dash you will have 75 ones, and now you will have 50 zeros, right? So you see, it is useful to flip a number of zeros, right? So that's why now you want to find the subarray. Now you want to find a subarray where the number of zeros are maximum, right? So if you assign 1 to zeros and minus 1 to ones, you can see the sum of the following subarray is how much? The sum of the following array is plus 1 into 75 minus 1 into 50. So it is equal to 25, right? So after converting this array, it will help you to add 25 extra ones. To S dash, right? So that's why you want to find an array. Subarray, where number of difference between 0 minus ones, right? Number of zeros minus number of ones is maximum, right? Right? Because it is maximum, the greater it will help you. So that's why you can assign 1 to zeros and minus 1 to ones, and then just find maximum subarray sum. Right? Because you want to find the maximum difference between number of ones and number of zeros. So you can just find the maximum subarray sum, and that will be your answer. So I hope it is clear. So do you have any more doubt, or we can move to the third problem? ब्रो लोकेश लाइक दो पार्शियल सॉरी मतलब दो हो गए थे थर्ड वाला आफ्टर कॉन्टेस्ट विच पार्ट टू चूज 10 10 10 let me see 10 10 10 1 right in this you can choose the following part 0 1 0 right because sum of this is how much sum of this is +1 right and like you can either choose this one also because somewhere is also +1 right you can choose any one of them because if you flip this you will get 1 0 and 1 and again as you can see the number of ones are increasing from 1 to 2. Yeah, so that was the second problem, and finding the maximum subarray sum is a standard problem, so I will not go over how to do that. So the answer is just find maximum subarray sum. Now let's move on to the third problem. Third problem was like the question was very straightforward. You were given some array a1, a2, a3, so on up to an, right? And you were given some variable k, right? What you had to do was you had to split the array into k paths. You had to split the array into k paths such that sum of bitwise or of these k segments is maximum. A segments is maximum, right? So you have been given an array. You want to split the array into k paths such that the sum of the bitwise or of k segments is maximum. So that was the problem, and another observation was that your n and k both were less than equal to 10 to the power 3 and your variables ai were less than equal to the power 20. So these were the constraints. So as you can see, we have 10 to the power 3 constraint, so we can do some kind of o to the power n square or n square log n kind of stuff, right? So we can do something like this. So if you think about this, the problem really like gives a hint about DP, right? So there is a naive DP. You can easily think about DP that works in n square. Sorry, n cube. You can easily think about a DP that works in n cube, right? So like if you are at some index I, right? We have some a1, a2, a3, so on up to ai up to an. If you think about the naive DP, right? Naive DP, right? Which works in O of n cube. What you can do is, if you are at some index I, right? If you're at some index I, you can say dp of I comma j is equal to how much? This means at index I and segment j is ending here. Segment j is ending here. This is how much? It is just equal to maximum of. You can iterate over all the lower indexes, right? So maximum of let's say x, which is less than I, right? dp of x comma j minus 1, right? Plus bitwise or from range x plus 1 to I, right? So basically the naive dp that works in n cube, what you do is for every index, you assume it is the endpoint of some segment j, and then to find dp of ij, you iterate over all the lower indexes, right? You iterate over all the lower indexes and assume every one of them to be the starting point, right? You assume every one of them to be the starting point. So we'll go max of x is less than I. It is, you can also, yeah, that will work. A dp of x less than equal to j, the dp of x j minus 1 plus or of x plus 1 comma. So basically you are iterating over all the lower indexes, assuming them to be the endpoint of segment j minus 1, and then assuming the following part is belonging to, this is or of x plus 1 comma j, right? So that is how it will work. So it will obviously be O of n cube, right? So for long for first is your index I, right? And then for index j, sorry, not for index j, for segment j. And then for dp, to find dp of ij, you have to iterate over all the lower indexes, right? So then you have to iterate over all the indexes. For index x less than I, dp of ij is equal to maximum of dp of x comma j minus 1 plus or of x plus 1 up to index I, right? So there are 3 for loops. Every one has a complexity of n. So our complexity will be O of n cube. Yeah. So that is the naive DP. So obviously our n is up to 10 to the power 3, so it will not work. So we have to somehow optimize this, right? So how can we optimize this? Let's see that. So to optimize this, the observation is that we can use the following thing. That our AI is only up to 2 to the power 20. Our AI is only up to 2 to the power 20, right? So there will be just 20 bits. There will be just 20 bits or 21 bits, you can say, in AI. And we don't need to iterate over all the lower indexes. Why so? Let's say we have A1, A2, A3, A4, so on up to some index AI. In, right? For this index AI, right? This index AI, we want to find dp of ij, right? And if you think about this, there will only be 20 set bits, right? There will only be 21 set bits. Let's say you find some number A7, where let's say it is something like 0 1 0 0, right? And then you find some number A3, which is again 0 1 0 0, right? As you can see, our this bit is already set. And again it is being set here, right? So for bitwise OR, we only need to set it once. We don't need to set it again and again, right? So if we go from AI to A7, it is enough to check for A7. We don't need to check for A3, right? Because checking for A3 is useless. Why do we need to check for A3? Because our bit is already set here. We don't need to check for A3 again, right? So this is how we will improve our complexity, right? So we will not iterate over all the lower indexes. We will just iterate over closest index with let's say bit b is set with where, or you can say iterate over closest index where bit b is set. So we can keep track of this. Right? So if I am at some index a1, a2, a3, that's ai, right? Let's say I am here. Then there will be just 20 indexes. Right? Less than this, where the bit will be set, right? So let's say the 17th bit is set here, the 16th bit is set here, the 9th bit is set here, the 5th bit is set here, the 3rd bit is set here, right? Then I just need to iterate over these indexes. I don't need to iterate over all the indexes, right? Because if the 70th bit is already set, I don't need to worry about all other indexes where 70th bit is set, right? Because I already have a 17th bit as set, right? So I just need to iterate over 20 indexes. So that is how we can optimize our DP. From, and first it was how much? It was DP n into n. One was for index I, one was for segment j, and one was for index x less than I, less than equal to I, right? So we optimize this, right? We don't need to iterate over for this n. We can optimize this to 20 now, right? So our complexity will be how much? It will be n into 20, right? So obviously our constraints are 10 to the power 3, so this will obviously work, right? So now our DP is how much? Our DP of I, okay, is equal to maximum of DP of let's say index x comma j minus 1 plus bitwise OR of x plus 1 up to index I, right? Where x belongs to my some set position which will store the closest bit set positions, right? X belongs to position, and the size of position will always be less than equal to 20, right? So you just iterate over 20 indexes. So that will be a solution to this problem, and I also have the code for this. If you guys want to see the code for this, here's the code. So I keep my vector to store the positions, and my OR, this will help me to find this OR, right? We also need to find the OR from x plus 1 to I, right? So when I'm storing a position x, I will also store the OR starting from that position, right? So I don't need stuff like segment tree for this, because that will also add an extra component of log n. You can also use segment tree to find the bitwise OR, but it will add an extra factor of log n, and I don't think that will be useful, right? Because it will just increase the time complexity more. So you can just keep another vector that will store your ORs. So we will iterate over a dp. I will set my dp of 0, 0 equal to 0. Then this is my index I. This is my index I. So I will check for set bits. If my bit is set, then I will set my position of k. It means that the kth bit is set in I plus 1, right? So I don't need to look for bit k to the left of this, right? So if I want to iterate over set bit k, I can just iterate over this index, right? And I'm updating my pause or k equal to v of I, right? Because now I have found the set bit here. So now my OR value will reset. Otherwise, I will update my pause OR of k or equal to vi. So what I'm doing here is, so I will start from here, right? So I'm at some index ai. So I will check if my kth bit is set here or not. If my kth bit is set here, then I will say my position of k, the closest position where you can find the kth bit as set is equal to I, and the OR starting from this index. The OR starting from this index is how much? Position of OR of k is equal to ai, right? Because it is starting from here now. This is when the kth bit is set. When the kth bit is set. Now, what if the kth bit is not set here? What if the kth bit is not set here? Then I am at some index ai. The kth bit is set at some other index. Let's say a of, let's say p, right? At some index before I, right? So I know my position of k is equal to how much? My position of k is equal to p, and my OR is how much? My OR is now position of OR of k, right? It was already up to here. Now I just need to add ai to it. So I will just say position of OR of k is equal to how much? Position of OR of k or ai. So that will suffice. Then I will iterate over my segments, right? So my j is equal to I plus 1, or you can just do b here. That will also work. J is greater than 0, minus j. Then I will iterate over my bits, right? So for k is 0, k is less than 21. If my dp of pause of it is impossible, then just continue. Otherwise, my dp of I plus 1 j is equal to how much? It is maximum of dp of I plus 1 j, or dp of pause of k minus 1 j minus 1, and pause or of k, right? So it is just the following formula. Yeah. So that will be it for the coordination OA. There was also the fourth problem that I was not able to solve, but I will still tell it. So you guys can try it on your own. So the fourth problem was problem 4. In problem 4, you were given some value A, some value B, and some value C. So there was some polynomial fx. And these values A, B, C will tell you some things about fx, right? So the value A tells you that f of 1 is equal to f of 2 is equal to f of 3, is equal to f of 4 up to f of a is equal to 1, right? So that means all these values are equal to 1. All these values are equal to 1. And the other thing is that b, that means f of a plus 1 is equal to b, right? And now we have to find the value of f of a plus c. We have to find the value of f of a plus c. So that was the problem. So we were given some polynomial, we were not given the polynomial fx. We had to like we were told that there was some polynomial fx, right? We don't know how it looks or how it works, but we were given three variables a, b, c that tells us the nature of the polynomial fx, right? Or some function fx. So my f of 1 is equal to f of 2 is equal to f of 3 up to f of a is equal to 1. So that is what my variable a tells me. And my variable b tells me that my f of a plus 1 is equal to b, right? So these are the two statements that were given in the problem. Using these two statements, I had to somehow find the value of f of a plus. And the constraints were my f of a was less than equal to 5 into 10 to the power 5. My b was less than equal to 10 to the power 9, and my c was less than equal to 5 into 10 to the power 5. Right? So these were the constraints. I have no idea how to solve this as of now. If any of you guys have an idea, do let me know. But I was thinking something like this, right? If that means the polynomial is at has value of 1 a times, right? A times it has value of 1, my value 1. So if I shift the origin upwards, right, you can say my f of x minus 1 has a roots, right? It will have a roots. So if something has a roots, it is obviously of type x to the power a plus x to the power b plus x to the power c plus x to the power c. This is, let's call this a1, a2, a3, a4. Sorry, not b, c. What I am doing here. Sorry for this. My polynomial will be of type a to the power 1 x to the power a plus a to the power 2 x to the power a minus 1, so on up to a to the power a plus 1. So not a to the power a plus 1, a comma a plus 1, and x to the power 0, right, equal to 0, right? So this will be the form of the polynomial. I don't know if I am thinking this correct or not. I don't know how to solve this. Yeah, so that was what I was thinking during the contest. So you can like kind of think of this as a falling polynomial of degree a, and maybe try to find these coefficients and then try to solve the equation. Yeah, so that was how I was thinking about this, and you can say this is my f of x. So you can like, if you can guess the coefficients, you can then set x equal to a plus c, then just solve it. I don't know if I'm thinking this in the correct way or not. If you guys do know how to solve this, do let me know here or on my Discord server. I'll be more than happy to hear about this. Yeah. So if you guys have any doubts, do let me know right now, or I will end the stream. The stream is over 45 minutes. It's good enough. So do any of you have a doubt about any problem? Problem third, problem second, problem first, or the fourth problem? So I think we are good with this, and I think I can end the stream right here. So yeah, I will see you guys with videos I think tomorrow morning, because I think there's a code quiz around today. yeah, there's a code for there's a code for this contest today. So I will see you guys tomorrow with videos from that contest. And that is it. So see you guys in the next one. Bye bye.